Alright, this video I'm going to focus on multiplying rational expressions. This is my second video, so if you have not watched the first one on multiplying rational expressions, I suggest you do that. So again, a quick review: when we're multiplying rational expressions, rational is the math term for fractions. So anytime we multiplied fractions like 1/2 times 3/5, anytime we wanted to multiply there, we multiplied the top, so 1 times 3, and the bottom, 2 times 5 is 10. So there's a lot going on. You're dealing with the top and the bottom at the same time. So that first step, we're dealing with multiplied top and bottom same time. So there's a lot of action going on there. So when I'm looking at these, I'm multiplying the rational expressions, and I need to state any restrictions. So a lot of what's going to happen is it's going to happen up top and it's going to happen up bottom, the numerator and the denominator. So first thing I'm going to do is I want to factor all my numerators, both my numerators and both my denominators. When I'm factoring, always look for a GCF first. That's a commonly missed piece, trying to find the GCF first. So if I have x squared minus 4x, and I'm looking for a GCF there, they both have an x in common, so I can pull an x out of both. So I can have x pulled out, and that would leave x minus 4 left behind. If I look in the denominator, x minus 1, if I want to factor with the GCF or factor out another way, there's nothing that can be done, so I'm going to leave that as x minus 1. Still my multiplication there. Now go to the top. I have x squared plus 3x minus 4. First want to check for a GCF. From all three terms, there's nothing all three of those have in common. So I'm going to have to use conventional factoring. So I'm looking for, since the setup of this, I'm looking for two numbers that multiply to -4 but add to 3. Two numbers that multiply to -4 but add to 3. That's going to be x plus 4 and x minus 1 is my two factors there. And then a denominator, I have 2x, so I'm going to leave that be. Before I actually do the multiplication here, what I want to do is I need to talk about restrictions. So before I start combining things and simplifying, let's talk about restrictions so I don't miss anything. Remember, with fractions, the one thing we want to avoid is having a 0 in the denominator, because then when we divide by 0, we can't do that. So what I'm going to do is I'm going to take each of the factors in my denominator, set them equal to 0, and solve. So over here the denominator is x minus 1. So if I set that equal to 0, I'm going to find, hey, x cannot be 1. If we plug in 1, we're going to divide by 0. That's issues. My denominator over here is 2x, so 2x is equal to 0. By the way, this one over here, I added 1 to both sides. 2x is equal to 0. If I divide by 2 to get x by itself, I get x cannot be 0. So those are my two restrictions. X cannot be 1, x cannot be 0. So going back to the problem, I have it all factored out. Now remember, we multiply the numerators, multiply the denominators. But when I multiply, I'm not technically going to multiply it all out. I'm going to keep it pretty separated. So in the numerator, I'm going to have an x times an x minus 4 times an x plus 4 times an x minus 1. In the denominator, I'm going to have an x minus 1 times a 2x. So what I've created is I've now gone from a multiplying problem to a simplifying irrational expressions problem. So what I'm looking for is I'm looking for common factors on top and bottom. And notice how I didn't multiply any of that out, because whenever we simplified rational expressions, we want everything factored. So the reason we can do that is we're looking for common factors in the numerator and the denominator. So the factor needs to be on top and bottom. We're not looking for the same thing top, same thing bottom. They have to be one top, one bottom. So what I see is I see an x minus 1 and an x minus 1. So factor for factor. I see this lone x over here and this x down here. So an x for an x there. And notice how there's no addition or subtraction connected to those. That's why I can do it. This x here wouldn't cancel with, say, this x inside the parentheses, because that x is subtracted by 4. That's why this one and that one can go. As you see, there's not much else left. So what I'm going to write is I'm just going to write what's left in my numerator. That's my top, and what's left in my denominator, the bottom. So up top, I'm going to have x minus 4 times x plus 4 divided by 2. Now that is my answer. There's no more simplifying with restrictions of x cannot be 1 and x cannot be 0. Notice how I did these before the simplifying. If I would have done it afterwards, I wouldn't have known that these were restrictions. So you do restrictions pretty early so you don't miss any. So to get one more example for you, again down here we're going to be multiplying these rational expressions. These are a little bit more complex. Remember, the first thing we want to do is factor and be careful of GCFs. So up in the numerator here, x squared minus 16, I'm looking for two numbers that multiply to negative 16. And notice how that kind of like middle x term is there. Two numbers that multiply to negative 16 but add to 0. That's going to be x plus 4, x minus 4. My denominator, x minus 9, can't do much with that, so we're going to leave it alone. Times, and let's factor here, two numbers that multiply to negative 90 but add to 1. Let's see, that is x plus 10 and x minus 9. In my denominator, looking for no GCF there. Two numbers that multiply to 40 but add to 14. X plus 4 and x plus 10. Now before I get to multiplying and simplifying there, we do want to go and find our restrictions. Again, restrictions, we cannot have a denominator of 0. So I'm going to take all my denominators, all the factors of my denominators, set them equal to 0 and solve. So x minus 9 is equal to 0. We get x cannot be 9. So there's one restriction. Take this x plus 4 equal to 0. Subtract 4, subtract 4. X cannot be negative 4. Take that x plus 10 equal to 0. Solve that. Minus 10, minus 10. X cannot be negative 10. So there's my three restrictions. Now that I've tackled that, have that done, I'm going to combine by multiplication here. So the top, the numerators get multiplied with numerators, denominators with denominators. So we have a pretty big fraction here. So in the numerator, I'm going to have x plus 4, x minus 4, x plus 10, x minus 9. In the denominator, x minus 9, x plus 4, x plus 10. So there's a lot going on there. So my two fractions became one giant one. Only thing left to do is I need to look for common factors in the top and the bottom. So I see x plus 10, x plus 10, x minus 9, x minus 9, x plus 4, x plus 4, and that's it. So I'm going to write what's left on top. My numerator, I have just an x minus 4. In my denominator, it looks like there's nothing there. It's really just 1. But if you divide anything by 1, like that, x minus 4 divided by 1, that's the same as x minus 4. If you wrote either or, I'll be fine with it. This is the most simplified answer here, though, x minus 4. But that's what we have. So you'd have left over just a 1 on bottom, x minus 4 on top, those three restrictions. So that was multiplying rational expressions 2 for the videos.